All right, AP kids, here is a reaction that we're going to balance where you will be able to use a coefficient that's fractional in front of one of the 9 elements. And when I say one of the 9, you guys should all know oxygen and nitrogen and hydrogen and chlorine and fluorine and bromine and iodine and phosphorus and sulfur. Those 9 elements are the only, and I repeat, only conditions by which you can put a fraction in front of them when you're balancing an equation. The purpose of using a fraction is it's a shortcut, and it cuts down the amount of work that you have to do to balance a reaction like this. Now, before we show you how to balance this reaction, this is a good time to mention what this reaction is, because you'll see quite a few of these, and at least you'll know what their proper name is. It's going to come up eventually, but this is a good time and place to point that out so we can kill a couple of birds with just one rock. All right, this compound C2H6, it's an organic compound. And because it's made up of carbon and hydrogen only, it's called a hydrocarbon. And because it's reacting with oxygen, we would call this a combustion reaction. All hydrocarbons, for the most part, are fuels. And when you combine them with oxygen, they burn. And as they burn, they form 2 distinct products all the time, regardless of what the identity of the hydrocarbon is. The hydrocarbon can be huge. This happens to be ethane. What you're going to form each time is carbon dioxide and water. Always. All right, so learn that, know it. Combustion of a hydrocarbon, you have to have oxygen as the other reactant, because without it, you can't have burning, you can't have combustion. And again, carbon dioxide and water. All right, so we're going to do this parallel style, just like we taught you before. In the same order, you're going to write down the atoms again. So for the carbon, we have 2. The hydrogen, we have 6. The oxygen, we have 2. On the carbon side here, 1, hydrogen 2, oxygen 3. All right. Business as usual, coefficients only, and pick your battles wisely. All right, if there's 2 carbons here, the strategic thing would be to make 2 carbons on the product side. And the way that you're going to do that is put a 2 in front of carbon dioxide. Remember, you got to recount. When you recount this, you're going to have 2 carbons. And now 2 times 2 is 4 plus 1. Don't forget the oxygen from the water. 4 and 1 is 5 oxygens. Okay. Remember, atoms like oxygen kind of work themselves out, but when you're doing combustion reactions, the oxygen is going to be the problem area, and by using fractions, you'll see how you're going to make it less of a problem and more of like a puzzle piece that you have to figure out, and it's easy after that. Okay, so let's do hydrogen. We have 6 and 2. If we put a 3 in front of the water molecule, that will remedy our hydrogen problem. So that becomes a 6. And now we got to recount the oxygens. So we have 2 times 2 is 4, and plus 3, 7. All right. Well, the carbon and the hydrogen is good, but the oxygen screws up everything. Now what? Here's what you're going to do. You would love to have 7 oxygens on the reactant side, because if you have 7 of them, you're going to end up balancing your reaction. But how in the heck are you going to get a 7 when there's a 2 there? Here's how you do it. You're going to put the number that you're trying to get your hands on, the 7, in the numerator. And you're going to put in the denominator the subscript that you are working with, which is a 2. So you're going to match the subscript with the denominator. So these 2 always match. Okay? When you multiply now the 7 by the 2, which is the subscript again, you're going to get 14. So 7 times 2 is 14, divided by 2 is 7. So you've accomplished the problem now. You now have 7 oxygens. But here's the caveat. You got to be really careful. You're not allowed to present a balanced equation with fractions, because you have to show that the law of conservation of matter or mass is holding true, and having a fraction in front of a molecule isn't going to cut it. The reason why we do this is for the mathematics. Now we got to do the chemistry. So there's no way you're going to have 7 halves of an oxygen molecule. The 7 halves was done strategically, mathematically, to get the number 7 as the outcome. And once again, you do this by matching the number you're trying to get your hands on, 7. The denominator comes from the subscript 2. And then you multiply the numerator by the subscript 14 and divide by the denominator 2 to get 7. All right, so how do you make this right? The way that you're going to make this right is you're going to multiply the entire reaction by the subscript, which is also, of course, the denominator, 2. So the whole reaction has to get multiplied by 2. So what does that mean? Your final reaction is 2 molecules of C2H6 combined with 7 molecules of O2 to give you 4 molecules of CO2 and 6 molecules of H2O. Now what you're going to do is just check your work one more time. 2 times 2 is 4 carbons. 6 times 2 is 12 hydrogens. 6 times 2 is 12 hydrogens. And now for the oxygens. 7 times 2 is 14. 4 times 2 is 8, plus 6 is 14. The reaction is now complete.